What we're going to do is we're going to write linear equations. There are two main equations that we're going to be working with. One is the point-slope form, where we plug in the slope, the x value, and the y value for the ordered pair. And then what we're going to do is we're going to simplify it to slope-intercept form. Now for the first example, we also need one more formula, and that's the slope formula. That would be y2 minus y1 over x2 minus x1. So for our first example, what we're going to do is we're going to find the slope. So we have m equals 6 minus 5 over 3 minus 2. That would be 1 over 1, which is 1. Now we get to pick a point. I'm going to pick the point 2, 5. It doesn't matter which point you pick. Either one is still going to give you the same result. When we plug it in, we go y minus 5, because 5 is our y value, equals 1. That's our slope. And then we have x minus 2. I'm going to distribute the 1 to each of the terms. So I have y minus 5 equals 1x minus 2. Then what I'm going to do is add the 5. And when I add the 5, what I'm going to get is y equals 1x, or just x, plus 3. Now, for the second problem, we're going to do the same thing. First thing that we're going to do is we're going to find our slope. So we have negative 3 minus a negative 7 over 5 minus 3. If we subtract a negative, we know that that's a positive. So negative 3 plus 7 is 4. 4 over 2 would be 2. We have our slope, and we're going to pick a point. I'm going to pick the point 5, negative 3. Once again, it doesn't matter. You could pick either point. They're both going to give you the same answer. So we have y plus 3. The reason that it's a plus is because when we subtract a negative, we know that it gives us a positive, equals 2, and then x minus 5. I'm going to distribute the 2 to each of the terms. So y plus 3 equals 2x minus 10. I'm going to subtract the 3, and when I do that, what I get is y equals 2x minus 13. Now, for letter C, what we're going to do is the same thing. First, we're going to find the slope. So m equals 3 minus a negative 1 over, and then it would be 8 minus 0. That would be 4 over 8, which is 1/2. I'm going to pick the point 0, negative 1. Once again, it doesn't matter which point you pick. So I'm going to put y plus 1, because a negative is a positive. I have 1/2, and then I have x minus 0. I'm going to distribute the 1/2 to each of the terms. So y plus 1 equals 1/2 x minus 0. Then when I subtract the 1, I get y equals 1/2 x minus 1. Now let's look at our next example. With these ones right here, what we're doing is we're looking at parallel lines. We know that parallel lines have the same slope. So when we're looking at our equation, what we're doing is we're looking for the slope of our equation. And we're writing an equation that is parallel to it. So we see that the slope is 2. So what we're going to do is we're going to write our equation with a slope of 2, and we're going to use the point 5, 1. We're going to use the same point slope form, y minus 1 equals 2, x minus 5. I'm going to distribute the 2 to each of the terms. So y minus 1 equals 2x minus 10. Then I'm going to add the 1, and I get y equals 2x minus 9. Now, looking at letter B. The first one, this was in slope-intercept form. This one is not. So technically, the 3 is not our slope. In order to figure out the slope, the y needs to be by itself. So I'm going to subtract the 3x. and I get y equals negative 3x plus 12. I see that my slope is negative 3, so I'm going to use my negative 3 slope. I'm going to use my point negative 2, 3, and I'm going to write my equation. Y minus 3 equals negative 3 x plus 2. Once again, the reason that I put a plus is because a negative and a negative make a positive. I distribute the negative 3. Y minus 3 equals negative 3x minus 6. I add the 3, and what I get is y equals negative 3x minus 3. Now, for our last example, what we're going to do is we're going to look at perpendicular lines. Perpendicular lines have the negative reciprocal. That means we change the sign and we flip the number. So whenever it says perpendicular, what we're going to do is we're going to look at our slope. We're going to take our slope and we're going to find our perpendicular slope. Now, just as a couple examples, the perpendicular line to 3 would be negative 1/3. The perpendicular line to 1/5 would be negative 5. Perpendicular to negative 4/5 would be 5/4. So here, our slope is 1/2, and so the perpendicular slope would be negative 2. So I'm going to use my negative 2, I'm going to use my negative 4 and 2, and I'm going to write my equation. Y minus 2 equals negative 2, x plus 4. I'm going to distribute the negative 2 to each of the terms. So y minus 2 equals negative 2x minus 8. Then when I add the 2, I get y equals negative 2x minus 6. Now for our last one. Once again, when we're looking at this, notice it's not in slope-intercept form. The y isn't by itself. So we first have to get the y by itself. So we're going to subtract the 3x. Then we get negative 2y equals negative 3x plus 8. We're going to divide it by negative 2. And we get y equals 3/2 x minus 4. We see that the slope is 3/2. So that means that our perpendicular slope would be negative 2/3. We're going to take our slope, we're going to take our point, and we're going to plug it in. Y minus 0 equals negative 2/3. And then what we have is x minus 6. The minus 0, of course, cancels. So we're just going to keep this as y. I'm going to distribute the negative 2/3 to each of the terms. So that would become negative 2/3 x. Negative and negative is a positive. This would be 6/1. So 2 times 6 is 12. 3 times 1 is 3. 12/3 gives us 4. And that would be our final answer.